Hi, this is another intro that I'm recording after everything is done. I was working on solving the hard starting issue of SC377, and the good news is I did solve it, but it was a bit of a journey to get there. I will present that all in this video, how I solved it and what the problem was. It will be out of chronological order though, because although I did work systematically, I kept jumping around a bit, and I had to change the order so it makes sense for the viewer how I progressed. So without further ado, let's get started. Hi, I am still working on the hard starting 377. I have talked to a few friends of mine. I'm part of a small Opel enthusiast group, and we help each other out if there are problems that somebody else might already have encountered. And it all boils down to either ground problems that are causing the hard starting, or I was made aware that there is a check valve in the fuel pump that might fail, and then the fuel pump doesn't work properly. Also, during my last test drive, I have noticed that the fuel pump is actually making noises. It sounds a bit like it's sucking air, but it's just probably rattling inside. I have my doubts that it's sucking air, but that's what the sound is like. Anyway, so I'm gonna do the fuel pump. I'm gonna go through all my ground points, but I thought I'll also try two other things. What surprises me is that the car runs properly once it runs. That means the alternator is generating voltage, and if that voltage is there, the car runs. So I'm now thinking that during starting I'm just not getting enough voltage, which would once again potentially be ground problems. And I want to verify that it's actually lacking fuel. So what I'm going to do is two things on 2 different days. Today I have just put a 4.6 kilo ohm resistor into the socket of the temperature sensor. It's actually called temperature sensor 2. That's the one, the injection system sensor in the water, not the one in the airbox. So that is something I'm going to try now, if that makes a difference how the car starts. And 4.7 kilo ohm tells the car it's a bit above freezing. 5.5 kilo ohm is freezing, so 0 centigrade, 32 Fahrenheit. And now it tells the car it's something around maybe 5 degrees Celsius. So it's much warmer than that. As you can see, me standing out here in a t-shirt, it's probably about 20 or 68 Fahrenheit. So if my assumption is correct, the car should take less than the usual 30 attempts to start. And the other thing I'm going to do tomorrow is supply voltage to the injection system through the fuel pump relay, through the fuel injection relay from an external source, and see what happens if I have confirmed that the fuel injection system sees the correct voltage. That should also hopefully make a change. So without any further talking, I'm gonna now show you in a shaky video where the temperature sensor in the water jacket is. It's not, there are two temperature sensors there. One is for the temperature gauge at the dash, and the other one is telling the fuel injection system what the current temperature is, water temperature is. Okay, let's go. Okay, the camera is now pointed to the front of the engine. You can recognize the U-shaped vacuum hose, as well as the thermostat housing and the oil filler cap. And the temperature sensor lives down here by the auxiliary air valve. And I have now pulled the plug off and put my 4.6 kilo ohm resistor in there. And I'm now gonna try to start the car and see if it starts any better. Okay, that was an interesting result, and I think that general fuel delivery is not a problem. Even with the pump that sounds like that and it's obviously on its way out, it is still starting well with the fake low temperature. So it could either be that maybe the fuel injection temperature sensor is bad, showing the wrong values, or still it's going to be a ground issue, not having enough voltage at the injection system. So tomorrow I'm going to do the test that I was talking about, where I supply an external voltage to the fuel injection system and see if that changes the starting behavior. If that changes it too, then the temperature sensor is not the problem. So we'll see, and it's going to be interesting. Yesterday I started the car with a 4.6 kilo ohm resistor in the temperature sensor plug, which was, I would think, something like 5 degrees Celsius, while it was in reality 20, and the car started on the second attempt. Today I'm going to go one further and put a 14 kilo ohm in. That's one that I have sitting around, so I'll try that one. And there must be a limit, because the last time I did pull the plug, and basically by that putting infinite resistance in the plug, the car did not start. I'm going to verify that today, if that was only that it didn't start back then, or if it really does not start with the plug pulled, if it does need some reading. So that's what I'm going to do, and I also need to know what my curve is, because it's not linear. It starts with 5.5 kilo ohm at 0 degree. These are the data points I know, and it goes down to the range, I think, of 200 ohm or something. So it's very drastic, the drop in resistance over temperature. So I need to figure out what that really is. For that reason, I pulled 3 resistors, 3 temperature sensors from the shelf, an original Bosch unit, an FAE unit, and Cambriare. So I'll see how similar these 3 are and what readings I should expect at what temperatures, and then I can go to the multi-plug of the injection computer and get my reading there, what my temperature sensor tells me, and then I will see if I'm off or if the sensor is okay and I'm still battling ground issues. Now I'm gonna put the plug back on and see if it starts now. My impression is that when the car has run once, it will start normally without any cranking and multiple cranks. This was an attempt with the sensor reconnected. I want to try, and it seems to work, that the car starts fine if it has run once before. So now I can at least avoid these sessions of 20-30 cranks until it starts. I'll just put a resistor in for now, and then the car starts and I can go further hunting what the problem might be. Now I'm gonna pull the plug again and want to see if the car does or does not start with infinite resistance. Okay, it does start, but it's running rough. This was an interesting result. Yesterday it started about, I think at the second attempt with 4.7 kilo ohm, and with a 14 kilo ohm it was struggling a bit, but after 4 attempts or 5 it did start also, so it still helped. And then I verified that the car will start again with the normal temperature sensor connected if it has been running before. And I also, it must have been a false memory, saw that the car does run and does start with the temperature sensor disconnected. However, it is shaking because it's running extremely rich then. I don't know what temperature that would correspond to, but so these are more data points, and then tomorrow I'm gonna do what I originally wanted to do today, is supply an external voltage to the injection system and see what the starting behavior is then. After that we should have a pretty systematic set of data that gives us some idea what is going on, and then the next thing is what will happen if I supply the external voltage, and in the end I'm gonna also chase any ground issue I might have. I'm gonna have to do the alternator, the injector, the alternator ground, the engine ground, and everything. And once that is all done and verified that the ground connection is okay, hopefully it might run. If not, I need to dig deeper and see if maybe the sensor is at fault. But we will figure that out, and I'm quite hopeful that the car will soon run as it should. Hi, as I had mentioned, I had to measure the resistance versus temperature curve of my water temperature sensor for the fuel injection, and there's going to be a little bit of data evaluation. So anybody who is a scientist or engineer or works in another math heavy profession doesn't need to watch this. You can skip ahead. This is all beginner's lab stuff. Okay, so here we have our temperature resistance versus temperature curve. These are the raw data. I started in my freezer at minus 18 centigrade. Then I did ice water and also measured some data points in the morning when I just had the ohm meter connected to the temperature sensor outside. That was a cold morning. And then here, these are data points when I was having the temperature sensor in water and was heating the water up. So now how do we fit this? Because of course what I really want is, in order to know what resistance the car should see at what temperature, I ideally wanted to describe it with an equation and not look it up in a table. There's a way to figure out whether this is an exponential function or a power rule. The way to do this would be, if this is an exponential function, you, instead of having linear temperature and linear resistance, you do the natural logarithm of the resistance on this axis. The natural logarithm is the inverse function of the exponential function, so this would turn this curve into a straight line. If it were a power rule, it would be different. You would take the logarithm, natural logarithm of the resistance over the natural logarithm of temperature. In that case, of course, we have to switch from Celsius to Kelvin, because you can't have negative logarithms. And the math behind it is shown in the next slide. The trick in both cases is to turn this into an equation of a straight line. And the equation of a straight line is our value y on the y-axis equals some factor of in front of x. The factor in front of x is the slope. This is basically, if you have a line, how many units to go vertical divided by how many units to go horizontal. That would be, for example, if it is 1 up over 2 to the side, it would be 1 divided by 2, it would be slope 1/2. If it is like this, 1 down over 2 to the side, it would be -1 up, basically 1 down, and 2 to the side would be -1/2. So you can always determine the slope if you have a graph. Just look at it and measure how much you go up to how much you go over the side to the side, and you have your factor m. B is the number where the straight line intercepts the y-axis. So the two things you need to do is you calculate your m, you look where it intercepts the y-axis, and that is all you need. Since we are interested in r and not in a logarithm of r, we do everything, we do e to the power on both sides. So we have e to the power ln r on the left side and e to the power mt plus b on the right side. Ln and exponential are inverse functions, so the r drops right through to the bottom and these two disappear, so we have r equals. And then if you have addition in an exponent, that means you can pull them out in front and you have that as a factor in front of it. So basically you might remember x squared times x to the third is x to the fifth. Basically x to the 2 plus 3. That's how it works. So I'm turning the x to the 2 plus 3 into x to the second and x to the third. So since b is a constant and e is a constant, this will turn into a constant. In the end, what we have, as I said, this drops right through the ln and the e function to the bottom. This constant in front of it, and e to the mt. M is the how much up and down over how much sideways that we calculate from our straight line. And from a regression in Excel that I'm going to show you later on, these two values come out. So this would be, the resistance is 5335.85 ohm times e to the negative 0.0349 temperature. If it was a power rule, we would do something similar but a little bit different. In this case, we do both axis logarithmic, so we have the natural logarithm of r on the left times equals m times natural logarithm of t plus b. So once again, we still have our y equals m times x plus b, except that the y-axis is now logarithmic and the x-axis is logarithmic. This logarithm rules, this m goes into the logarithm as an exponent of t. So in the end now we have the logarithm of r equals a logarithm of t to the m plus b. And once again we shift everything up in the exponential function. But once again, this is e to the ln r on the left side equals e to the whatever we have here, ln t to the m plus b. Once again, we pull e to the b in front, and then we would have, as we had before, e to the b times e to the ln t to the m, and e to the ln just falls away. So in the end we have this constant and t to the m. So once again, this m is this m that we determine out of the slope of our now linear curve. And m in this case turned out to be this, and see this. So now the resistance curve in that case, if it was a power rule, would be r equals 70.16 times temperature to the power negative 10.965. This is the logarithmic fit, where we have a logarithm of resistance over linear temperature. And this would be correct if this is an exponential function. The line here is a linear regression that I did with Excel, and the parameter are negative 0.0349 for our M and 8.6187 for B. However, this needs to be, in the end, it's e to the power 8.6187. And what you can see is there's a slight deviation down here at high temperatures and also here at low temperatures. This is now the double logarithmic fit. That is the logarithm of resistance over the logarithm of temperature, and as I said, I had to go to Kelvin so I don't get any negative logarithms. And it is obvious, in my opinion, that this is a much better fit because it has no big deviations down here or at low temperatures. The fit parameters for this line are negative 10 to the 965 and B is 70.16. Okay, and this is the result. I have now drawn both, again, linear, so linear resistance over linear temperature, and the black line is the calculated resistance line from the fit. So instead of a straight line, of course, when we put this back into linear, then this turns back into a curved line. And this would be the 5335.85 ohm times e to the negative 0.349 times temperature. And at high temperatures, the deviation is now practically non-existent, but at low temperatures we still have this deviation here. This is the power fit, and it is obvious that this is much better fit than the exponential function. There is no deviation at high temperatures, and there is practically no deviation at low temperatures. So in my opinion, the correct fit to describe the characteristic of the temperature sensor is R equals 70.16 times T to the negative 10.965. And this is the line or the equation with which I will be working from now on. And this becomes important to see if you give the car a certain resistance, then you can always calculate what temperature it thinks the environment is. This is also something that I have used before when a car did not start at all. I, for example, was at 20 degrees, which would be something around 2.5 kilo ohm, if I see that correctly. And then instead of 3.5 kilo ohm, I put something like 6-7 kilo ohm. So the car was all of a sudden thinking it was below freezing, and then it started easier, which of course is just a crutch. It's not a solution. But that is how you can get a car started if it's really a hard starter. Okay. So again, one, 2, 3, 4, 5. I'm holding this, and then number 12 is the open one, and we're going here, and there is absolutely nothing. I'm pushing in, and nothing. This one is actually now hanging there. At least it was. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm really pressing in absolutely nothing. and it does work. So now the same thing in the front. First I'm gonna go, which one is ground again? Five is ground. I'm now going into 5 and holding the other one against the door lock pin. 1, 2, 3, 4, 5. Holding it. Door lock pin. Now I do have ground. That's interesting. It's still connected to pin 5. And now I do have ground here. But if I go to the injector plug, neither side, neither this one, and I am down to the metal here, nor the other one has any connection. Anyway, so there's nothing here. Now I'm gonna connect pin 13. Nothing here, and here are the, yesterday I had 96 ohm, now it's mega ohm. That's all I see, and I do not understand how I can see mega ohm here, have no ground, and the engine still sees whether I plug or unplug the temperature sensor. It's very strange. But I have to repair these lines first and then go from there. Okay, I'm gonna try to start pulling the harness out and showing you what they did to it. The first thing I'm gonna do is take a few vacuum lines out just to make it easier. And out of the way. The screw I put right back here. Okay, now I'm going to start to disconnect things. Temperature sensor. Number 1, 2, 3, 4, 5 and 6 injector plug. And I should be able to pull this out here. Okay, and that is this part of the harness out. As you can see, it has been cut and reconnected here. There's all sorts of exposed wiring,
The harness is brittle. When you bend it, it cracks. So I think the only way to do this is to replace the harness.
Out of the car. That took a lot longer than expected, but here's what we have. Same thing, just in the old cruddy version. It's really basically everything sort of original except for the branch near the injectors. That branch has been completely butchered. And now the next step is to put the new one in. One of the reasons this took so long is that the injection harness was underneath everything, and I assume that it goes in first when they built the car, or did go in first when they built the cars, and it's probably not that often that one is being changed, so that was my bad luck today, but otherwise it worked, was straightforward. Annoying, but straightforward.
Okay, my phone stopped recording and I don't know when. So the new harness is in. I still need to tidy up. It's just hanging there for the moment. I just want to see if this made a difference. It should, at least from the plug when it was on the bench. I could see the 4.6 kilo ohm that I put in. So I hope it also, now the ECU sees the temperature sensor. Now it's time to connect the battery, reconnect the ECU to the plug, and then I have enough fire extinguishers here just in case I made an awful mistake that I can save the car. So fingers crossed. I cannot believe it. This is highly unusual. As I said, I'm the person for whom 50-50 decisions go wrong 90% of the time, and this was starting at the first attempt. So everything I did was chasing nothing but this stupid wire to the temperature sensor, and that was it. Of course, it doesn't hurt the car to have a new wiring harness for the injection. That's gonna help a lot. I'm gonna try again tomorrow, see if it starts on the first attempt again, but I have no reason to believe it wouldn't. That is really, really a nice success. I can't believe it. And then once I'm done with that and it's verified and I have tidied up the injection harness, then I'll start to do something fun, which will be starting engine compartment cosmetics. Taking things away, painting the area, and slowly but surely making the engine bay nice. Once that is achieved, I'm going to start welding my way around the rust spots. There are many, but not big ones. The only big deal is that I will have to take the rear window out, and that is hard to do without breaking it. I'll see if that works, but I am really happy that this went the way it did. It's a day after replacing the fuel injection harness on 377, and this will be my first cold start attempt. Based on this result, I would now argue that the cold start problem of SC377 is solved. And I hope that from now on the car will run when I want it to run and not when it wants to run. This is a success, but it has taken quite a while to get here. As I was working on the fuel injection harness and had the old harness out, I realized I had a second problem. It was not just that the temperature sensor wire was interrupted. I also had a wire just hanging there, and that is this one. This is the branch that goes across the back of the engine, this wire to the starter, and this one to the magnetic switch of the starter. So basically that wire is powered as you turn the key to start the car. Once you let go, it is unpowered. So what that does is it runs the fuel pump while starting. And after that, as you might remember, if you deflect the airflow sensor flap, the fuel pump comes on. So when once the engine is running, there's airflow and the deflection. Then the fuel pump power is routed through the airflow sensor. In other words, I was trying to start the car with a non-functioning temperature sensor, and I also did not get any fuel unless the flap was deflected. And I haven't, of course, no way to check that, but I assume with the low cranking RPM that there's at best a bit of a flicker or something and short bursts of fuel or something, but not what the car needed. So now with that connected, that must have helped as well, that now as soon as I turn the key, the fuel pump comes on and pumps fuel. So as I said, it was not one problem, it was two problems I had.